So with that, we're moving on to Azure Virtual Machines. And so to start looking at Azure Virtual Machines, we're going to look at VM sizes, supported workloads, licensing of how things work inside there, portability about where I can take my VMs, and then lastly, the cloud services that these run underneath. So with that, let's start with a demo. And to do that, I'm going to share my desktop out. And so the first thing I'm going to do is log into the portal as soon as this comes up for you. So the Azure Management Portal is the area that Dan already showed, and we're going to focus just on the virtual machine section of that. All right, so that should be up and available. So in this, I'm going to click on the left side here and go into virtual machines. Now, the first thing I'm going to do when I work in a virtual machine, we'll go through some more of this later, is I can choose my virtual machine and remote control that right here by connecting to it, which will bring up an RDP session to that box. But I want to create a new one, and so I'll hit New down here, and I'm going to choose From Gallery. From Gallery gives me my choices, and now to choose from the list of platform images that we already have at Microsoft in Azure, all set up and available for you, or you'll be able to use your own images. So if I go down through this list of the images, certainly have Windows Data Center of 2012, 2012 R2. I have Server 2008 R2. And then I have some servers with things installed on it already. Like here we have a SharePoint. It's a server, 2012 Data Center server with the SharePoint 2013 trial on it. I have boxes with different versions of server as well as SQL Server installed on that. Then I have further on down Visual Studio pre-installed, and then other things such as Oracle. So Oracle's WebLogic server. And so it's not just Windows boxes we have pre-images for. OpenSUSE and Ubuntu, OpenLogic. So, and then here's some of my own images that I've positioned up there. So what I'm going to start with is just take a Windows Server 2012 R2 data center, because it's our latest and greatest, and start to build one of those. So I click Next. I give it a name. I choose the size that I want of it. Right here I've got a 1 core with a 1.75 gig of RAM. Or I can go smaller or larger. I can go all the way up to 8 cores at with 56 gigabytes of RAM. Or I can choose maybe an extra large one with 8 cores. For this, I'm just going to choose, we'll go with a large core and 7 gig of RAM just because I'd like a bigger server. When you choose those, you also change the size of bandwidth as well for your box. You have to set up a username that's unique. You can't use administrator. You do have to use a very complex password. We look for complex characters so that you can't just use the password, so that it does create a bit more difficulty for someone to guess your passwords and get in. Now I can choose to create a new cloud service here, or I can choose one that's previously there. We'll explain more about that later. I'm just going to go with a brand new cloud service here. And then I get to choose the network I drop into. So I can choose affinity groups or areas of the country or of the world that I'm going to place this. Like I could choose this to provision in North Europe, Western Europe, Eastern US, Western US, or Asia. Or I can pre-configure things that I want it to build within, and I can call that an affinity group. And in that affinity group, I can have it choose what network it's going to add to, or I'm going to actually have it go into the BJL network, my standard network, which is this subnet. And then a storage account, I can choose my storage accounts of where the data is going to be stored, or I can have it create a brand new storage account. I'll just choose one of my already created storage accounts. Lastly, on availability set, This I can pair this with other servers so that I can create highly available servers, that one of those servers will always be up. And I'm not going to do that at this point. Just hit next. This section here is setting up a firewall rule as we come in from the internet of how I can access this server. And so by default, I'm going to have a random high port created that maps to port 3389 for my remote control of RDP, as well as I can enable PowerShell. It's enabled by default here to do remote PowerShell commands to manage my system. I can turn all of these off and have to VPN in to manage my servers in my network, which is a much higher security way to do it. We'll talk about a little bit more when we get to the network section. But I hit the checkbox at the bottom, hit create, and what we see here then is Server 2012 right up here, the Azure BJL server. It's starting provisioning. And so this server is going to take about 5 minutes, roughly around there is how long it takes, and I'll have a server up and available, ready to go, out well internet connected. So let's go back to the slides. All right. And as we wait for my presentation to come back up, so that was what it takes to create a virtual machine. Now, if we look at the different sizes that we saw there, we saw the extra small, and Dan had showed that was 2 cents per service hour, and it is charged per minute, so we do break down to a per minute charge. So as I go and run an A7, for example, that is $2.04 an hour, I do like to play with these because as we get up into this range, your connection is over 400 gigabit per second to the internet. We're in the extra small, we're at 50 gigabit up and download speeds to the internet, which is kind of fun to play. As the larger ones, if you go to the different speed test sites on the internet, quite often they can't keep up to the speed of this server. So it's kind of fun to go look around and play with. But in addition, it changes not only the size and speed to the internet, as well as your cost. It changes things such as how many cores you have. And when we see that, 1.66 gigahertz, that's the lowest minimum. Generally, what I'm seeing on my box is I have AMD Opteron processors at 2 some gigahertz in the system. But we also change the RAM in addition to that as we go forward. Before I move on, another piece that's changed is on the disk as far as how many data disks I can connect up to it. So in my VM, I can add multiple disks to the VM. And so not only do I have my C drive there, I have a D drive as well. That's temporary storage. Then I can add more disks to my server, E, F, I'll just keep adding disks where I can span those together. If I span them together, I'm able to get further speed improvements because your SLA on those disks are 100 IOPS per disk. So here on the medium server, if I put in 4 disks, I can span those across, stripe them basically, and I can get 400 IOPS, which I would expect out of that disk at that point. If we look at what we have in the Azure platform images, what we're riding on top of is we're doing this on top of Hyper-V. So things that work in Hyper-V work up here, but we have platform images pre-built. Certainly you can upload your own images, but the platform images we have are the current Microsoft Server 2012, 2012 R2, this deck saying preview for R2 that's actually been updated to the full RTM version of R2 at this point, and then different versions of Unix. So we have multiple images, but certainly you can create your own image and upload that into Azure, which we will be taking in the lab and doing that aspect today of grabbing an image and bringing it in, so you'll learn how to do that. So what about software? One of the things that we do in Azure is we have the option at least to cover software licensing as well as the cost of the server, the power, the cooling, the data center, the geo-redundancy. So it's not just the VM that you're getting. In the Windows realm, you're getting a Windows Server license included with that. And so therefore, if I'm going to grab one of those pre-built BizTalk servers, that BizTalk server license will be included in there as well. And so therefore, that charge is a little higher. The other thing is Dan went through that calculator before. I hope you noticed, well, it's complex, and we do these at the cheapest we can, so there's not a pricing of, oh, well, I just want to know that I pay $100 a month and this is what I have with these limits. We charge per gigabyte stored and all that kind of stuff. That's because we're charging at extreme low margins, and so the cost you're getting, other providers, and we would expect if you're going to be a provider, you might build on top of Azure and have your platform on top of Azure charging your customers those bulk prices, and then you can pocket the difference. So it's not uncommon to see other services on top of ours selling backup with their backup agent, even a flat rate, and that stuff all stores in our site. And they pay us, you pay them, as far as that type of a customer. And so if you're looking at a business like that, Azure is certainly one of the environments for you to consider as that back end. But our OSs are included, our products for BizTalk, for SQL, those can be included in your licensing of that. Or if you have your enterprise licenses, you can certainly build your image, put SQL on there, upload that into Azure, and run your environment that way with your corporate enterprise licenses, as opposed to paying for that through your license of inside Azure. As far as other apps that you may run in here, you pay however your vendor expects you to license their software. So if you're running an app that is, let's say, from Oracle, you pay Oracle how Oracle expects to pay. But that is another nice thing of Azure, is we are the one hosting provider that Oracle certifies to run their applications inside. So they don't certify any other, at least last I checked, hosting provider to run their services. Now, one of the other aspects here is we build Azure first for platform as a service. And Dan explained earlier what platform as a service is. That's building apps that are specifically created to run in not only a public cloud environment, but in a environment of internet scale, where I can just throw and spin up more machines to scale up. And then as I want to scale down, I can turn off those machines. And it happens seamless to the end user. So that's built into the platform as a service model. We see platform as a service as the future of development and of how services will run. But the world's not there yet, right? I mean, certainly there's a lot of platform as a service applications out there today, but there's still a lot of old applications that, like Microsoft Exchange. Not that I'm calling it old, but if you think about it, you don't spin up multiple mailbox servers and have no impact to the users as far as them hitting those servers for scaling out. We have other aspects that you have to do to think about how that scales. So we have a lot of apps that you need a full-blown server for. One of the other benefits of platforms as a service is you don't have to manage the server OS. You don't have to manage the patch level. You don't have to manage anything. You run on top of a runtime, so you manage your code and your data. Well, when we get to this infrastructure as a service, you have to manage the whole operating system, right? For the OS and how it functions, how it's configured, as well as all the patching and all that. And so it makes it harder to be highly available. So that was not the initial goal of Azure, was not these virtual machines. It's something that came later. And so what we did is we built basically a service that then a virtual machine we have fitting underneath. And so a cloud service in this graphic is wrapping around the VM. The VM lives underneath this cloud service. And a cloud service basically has a public IP address, a public DNS name, an internet firewall, as well as a load balancer. And so it's a boundary. I don't have to run just one virtual machine under there.
Hey Brian, let me just, if I could, throw an example of that. And whenever we think about platform as a service, and in particular a cloud service, or whatever we refer to as a cloud service, it's not the same as a service in what we used to consider as an IT pro. We used to consider a service as a small app or something that runs on a server that provides a service to the network. But in a cloud world, a service has a very different definition, because a service could be, it's not an application running on a server. In fact, many times, most of the time I would argue to say, it is actually many servers running many services as we used to know them in order for that one service to be rendered. So as an example, just take Office 365 as an example, which you guys can kind of picture how big that is. Right? You're not going to get that to run we kind of have a picture of how big Exchange is and how many servers are needed to run Exchange, and yet that is only one small piece of Office 365. But yet Office 365 is a service, right? So as we move up the scale of cloud services, your custom app that's running as a platform as a service, or your cloud service might have, it might have 1, 2, 3, 4, 10, 20, web front ends. It might have a back-end database server or two. It might have back-end reporting services. It might have back-end data warehousing services. It might have back-end workflow services, all to support that one service that you're providing. So a cloud service is not a traditional service that we come to know over the decades past. It is an entire system, an entire set of infrastructure that's needed to run that one service. So it's a different way of looking at things.
Thanks, Dan. Yeah, and we do see that as the way of the future. But before we get there, there's still a lot of other stuff we need to run, right? And taking our current servers and uploading them into Azure, or creating new servers for new things we want to do into Azure makes a lot of sense. And so that's where the VM role came from. And as we look at that, it's not just one VM I can run under a service. I can run multiples. And so I think it's 50. Dan, do you remember the exact number that as the max VMs per service?
I don't recall. Sorry.
For some reason, I think it's 50, just off the top of my head. But I've never hit that level under one service. And what that is all those servers will share the same public IP address. They'll share the same public DNS name. And so they all ride within that. They all have on themselves their own unique address. So let's say it's a 10.0.0.1 network or 10.0.0 network. First VM, let's say it has address 10.0.0.1. The next one will have 2, the next one 3, the next one 4. They all have their own unique IP address locally bound inside them like we're all used to. But then as they map out to the internet, they all go over the exact same internet address. And they can even share that same port across there, and we could load balance across those servers. And so when we build these virtual machines, we either build them one-to-one with their own cloud service so that they have their own unique external IP address, or we can multiple within there. And initially that was the first way we could get a load balancing firewall across in front of them. We do have other ways to do that are currently in beta right now, but that was the initial way. Now we can get servers that are in their own cloud service into basically a round robin or some other type of scale out ability. But this is the initial way we could do that. And the reason this is because they're fitting under this cloud service, which was really what Azure was originally built for, was for services like this. So if we have two servers in there, how do we remote control them? There's two ways we could do it. One, we could VPN in and then directly connect up to their 10.0 address. Or if the way we're setting it up by default is that we're not setting up that virtual private network. You're actually going to connect over the internet. And so the way it would happen is, as I go to remote control VM1, I'm connecting up to a high port, and in this, it's a random number, but in this example, it's 5586. So my remote desktop client on my machine says connect up to port 5586, and then that actually controls VM1. And then when I want to control VM number 2, I connect up to port 5587, and then that connects to VM2. So that's how we're making those connections work to specifically target one of those VMs underneath that same cloud service from the internet. And then, of course, if I want to load balance across them, I would set up a single port that just round robins across that. You don't want to do that for administration because then you wouldn't know what server you're hitting. But certainly for scaling up like a web server, we would load balance on the same port. So I mentioned you can use your own images. And so basically what we do is in Hyper-V, whether it's on Windows 8 or on Server 2012 or any of the other earlier servers, we can create a VHD file, a container for our virtualization, and build a server within there. And then we can upload that into the Azure data store, into Azure Storage. And then from there I can import it as a virtual machine, and then I can provision virtual machines off of that image, just like you saw me do a little while ago, where 5 minutes later I have another server up and running. That server can be off your standard image. And so one of the things I should mention is you do want to sysprep those servers. Traditionally, I had not sysprepped for a while, and I just was making copies of VHDs. Even though it was not the supported way from Microsoft, I found it was fast and worked well. The downside I found out, especially as you hit Server 2012, is you cannot add a server to the Active Directory that has the same SID, the same unique identifier, as one of the domain controllers. It will block that and warn you that is exactly what you're trying to do, and it's not allowed. The other thing is we find that there was a message for a while that SIDs don't matter, and what we find out is they do matter. They matter to SQL. They matter to a Novell networking client. They matter to different areas, and so if you've ever had one of those troubleshooting nightmares where it's really hard to figure out what's going wrong, if you enjoy that work, then you might want to use the same SIDs, because that's kind of what you run into. So make sure you do sysprep your machines. And what that is the first time I went looking for sysprep, I went to download it off the internet. And it took me probably a half hour of searching Bing as well as Google as well as anything else that would let me search it. And I couldn't find anything anywhere where to find sysprep.exe. Just to save you that time, if you didn't know it already, it's built into every version of server in the c:/Windows/System32/sysprep subdirectory. And you run sysprep.exe, you generalize the operating system, and it sets it for the out-of-box experience like it was the first time you installed and ran, and it not only changes that SID, it sets up the environment for the first time. So that is what you want to do before you upload your image, so that then you use that as your base image to then create multiple. It's basically a template. Then you can create multiple servers off of that, and they'll all be fine. But do make sure you sysprep. Now, when I create my on-premise virtual machines in Hyper-V, and I have machines that I create up in the cloud, like off of our platform images up there, or whether I use your custom image that you've uploaded there, those things are portable. And what I mean by that is I can take VMs that I have on-prem, and I can copy them up to the cloud, as we'll do today in the lab. Further, things that I have up in the cloud, I can download those images, and then I can throw them on Hyper-V in my own lab or on my desktop if I'm running Windows 8 or higher. So virtual machines can be run at any one of those spots, and you can trade them back and forth between those areas. So as we bring our own server to the cloud, that's a great way to do it. What we're going to do today is we're going to grab the Server 2012 R2 VHD file off the internet, and we'll just register for that. We'll download. First, what we'll do is we'll create a server in Azure. We'll remote control that server. From that web browser, we'll go to Microsoft.com and download that file. It will actually go pretty quick because I mentioned these are pretty well-connected servers. And so that'll download that VHD file of Server 2012 R2, and we'll just pretend that that's your custom image that you've created. Certainly, it should go rather fast. We'll take that VHD file then, and then we'll copy that into Azure Storage from inside that VHD, which again goes pretty quick because in that case we're actually in the same data center between that virtual machine and Azure Storage, and it'll pop that into there, and then we'll place that into the system. And so that is what we're planning to do today on this. Let's go look at those virtual machines in the management portal, and we'll take a look at a little bit more of what we can do to the virtual machines, to the VMs. All right, as this loads, where I'm going to be is in my virtual machine management console. And we'll focus again on the machines here. There we go. So in my virtual machine, we see that the VM that I created previously is up and running. And if I click on that server, go in to manage it. This is one of the areas I can get different tools, such as the command line tools to manage it off of this panel here. I can tell it not to show me this panel next time. I can find the forums and learn more information about managing this environment. The other is at the top here. These are tabs. It took me a long time to figure that out the first time I was playing with Azure. The first tab we're going to go into is the dashboard. And this gives an overview of this specific virtual machine itself. It tells us how long it's been up and available. So at 11:55, we created it, and here's the work that it's been doing, how much network traffic it's had, how much CPU traffic it's had. If we're using any of the services, such as auto scale, or if we've got a web point, an endpoint set, and if we're load balancing that, it'll tell us about that. It gives us the base information here, the quick glance. Okay, it is running. Its name from the internet connectivity aspect is Azure bjl.cloudapp.net. That first name has to be unique. The reason it has to be unique is because everyone else has cloudapp.net. So as you create your virtual machines today, we're in our lab guide, we specify use your initials and then something else on the name there. You may have to go more unique than just your initials, because a lot of people have used this, and so a lot of initials have been taken, and a lot of different names have been taken. Here I did Azure BJL, and that was not taken yet. So there's certainly easy unique names, but they will have to be unique for this first part. Then it shows me my public IP address. So this is the IP address I have out on the internet. This is my cloud services IP address. If I go further, here's my internal IP address. So this server's unique address is 172.16.1.5. And then it tells me about the size of that machine and that kind of stuff, as well as the location where I have it contained. So if we go to the next tab, which is monitor, we can see different things of what's going on the server, whether it's the CPU usage. I can, by default, it's going to record these things. I can remove these metrics or add them back if I want. If I remove a metric, the historical data of that metric will be lost, and I won't start recording it until I add it back. Now this is the tab that I couldn't find for a long time, endpoints. If you remember when we first created it, there were two endpoints that were created. One was for the remote desktop connection, and one was for PowerShell. Well, I initially went to play with Azure right away, and I set up a free trial, spun up a server, and then I went and threw some services on there that I tried to hit from the internet. Like I had a web server on there. If you load IIS up on here, you can see it locally. You can hit it at the loopback adapter address. You'd even be able to hit it at that local 172 address that we saw a second ago. But on the internet, I couldn't get it. I tried turning off the Windows firewall. I tried all kinds of things. What I needed to do was find the endpoint section here, hit add. I'll do a standalone endpoint here instead of load balancing with others. And then I'll basically add a HTTP address, right, mapping port 80 to port 80. Hit create. And now it's going to add to the firewall from the internet, it's going to add the ability to port 80 to be hit by this server from the internet. So this endpoint section is very important if you plan to do services from the internet. If you want to make a really secure environment again, I mentioned it before, if I remove all of these, it's very secure and can't be hit from the internet. If you want to manage it, you'll have to set up a VPN to that local network so that then you can manage it locally at its local 172 address. The last point on the virtual machines is this configure tab. It allows me to set different pieces here. not only monitoring it to see if it's up and awake, but this is the piece here that's of interest to me, which is I can change the size of this machine. So right now we set it up with 4 cores and 7 gig of memory. If I want to keep this machine up and running and keep the IP address and all that stuff, but it's not going to be hit very hard, I'll change that to maybe an extra small. And now I'm only paying 2 cents per hour to have this server up here, as opposed to if I went with the A7, that's about $2.04 per hour. So huge difference in price, huge difference in scale of the server as well. But I can change these. It will require a reboot. As I hit save on that, it'll warn me. Are you sure you want to make that change? The Azure machine could be restarted, and I hit no and I'm keeping it, but it will be restarted. You can't change out the number of CPUs and the amount of RAM like that without restarting your server. So it will restart as I do that. But I am able to make those changes of that server without doing anything else. And it just basically will reboot, reprovision up on another side, and I'll be running there. So that's just an overview of a little bit more of what we have in the virtual machine section. And I mentioned disks before. This is where we would find disks that are part of the virtual machine environment. On those virtual machines, I can click into one of those VMs like I did before. I'll click back into that Azure VM from dashboard. I can basically go and say add a new disk, an empty disk. And so I can add disks to that server while it's running. I don't have to reboot that server. It's just like plugging in a disk to any server while it's running. Then I would have to go into the disk management and make some configuration changes there. But that's pretty much the quick run-through of what we can do with these virtual machines once we've created them. All right. So back to the presentation. Now, availability sets. If I create an availability set, what I will do is I'll take 2 virtual machines and I'll have them in the same cloud service and I'll set them up as an availability set. When I do that, I get a higher SLA. My standard SLA on the VMs, virtual machines up in Azure, is 99.9 is the standard SLA. But if I put up 2 virtual machines, I can get 99.95 of an SLA. And that's 4.38 hours of downtime a year. So why we can offer that is because these servers are set up in basically different areas, different fault-tolerant sections. So if we think about that, what I've got is I've got a rack where I put one server, and then the other server that I have fault-tolerant with that server, I put in a completely different rack. And so when we run patches, it's in a different patching domain, and we won't patch both servers at the same time as far as their host or anything that we do. The OS itself is something that you manage, and so you have to be careful not to turn off both of those servers at the same time. But from our updating of the hypervisor and the different things inside Azure, we make sure that we don't update the areas where those servers live at the same time. The other thing is the rack itself, the power that's supplied to it. Those areas are in different sections. They're in different fault-tolerant domains, so different racks, and supplied by a different. Not that we have a power cord laying out, but if you were to walk by and trip over a power cord kind of thing and kick it out, let's say someone went in and unhooked up the power to a rack, it brings down that rack, not the other rack, not both virtual machines for you. And so those fault-tolerant domains are kind of nice in that sense. The other thing it sets up is back to that load balancer, back to that layer 7 switch in front of it. We can take a port, and in this case we're taking port 443, and we're going to have that one port on that one single public IP address, that one single DNS name externally. When people hit that, it will round robin it hand it off to VM1, and then to VM2, and then back to VM1. And if I add more machines in there, it will add it will lengthen that round-robin list. So this is how I get not only high availability, this is how I get that scale as well. So if we look at that high availability, it's not just on the front-end servers, right? I can set up high availability between, first, my front-end web servers, and not just two, but in this graph we have two. So that load balancer front-ends those. And then I can set up other VMs, such as a SQL VM, and I can do SQL mirroring between two VMs, have those highly available, so that I can bring down any one of those servers. In this case, I could actually bring down two of those servers, as long as one SQL and one IIS server, and we don't have downtime. So from that perspective, I can create highly available environments, whether I'm using load balancers in front of it or whether I'm using other technology to create that redundancy. I can specify and create those types of networks and that type of environment inside Azure. There's a new tool that we have that is in preview, which is auto-scaling up the Azure VMs as well. And so based on things such as, has the CPU utilization been over 50% for the last 10 minutes or other types of criteria, we can say, take this VM that I have sitting turned off and turn it on. And so we can scale up. And then, oh, you know what, it's been down at 0% utilization for the last 10 minutes, let's go turn off one of those VMs. So the nice thing that this gets you here is not only does it get you the ability to scale up to jumps and load, but it also gets you the added savings of not paying for virtual machines when you're not using them. So I have one VM up and running in a cloud service. It spins up other VMs inside that cloud service to scale up and then spin those back down. Kind of nice, and able to do it automatically. Previously, before this feature was added to Azure, it was something that customers did on their own and had to script out on their own, which is certainly possible. And if you need to do more things than we offer, you need to do off different criteria based than just standard CPU load. If you have other things inside your app that you want to do, you can custom build that into your environment. But we do have this as a standard offering inside Azure. As we look at virtual machines, there's other things such as disaster recovery that Azure is good for. And so in a virtual machine recovery, we talked about taking and backing up data to Azure storage, but there's other things that customers are doing, such as we can create that virtual network up in Azure. We'll talk more about that in the networking section. But that's an extension of our corporate network, or it can be. And so what we do is we create a site-to-site VPN tunnel, or we can use an MPLS network and have that our network or your network in Azure, right? Not our entire network, just your network section as a part of that MPLS network. If you do that, or the standard way is to use a VPN tunnel, a site-to-site tunnel, that network inside Azure is just like your own remote office or your own remote data center. And so what you can do then is you can just spin up a server out there, install Active Directory on that server, and have that as part of your forest. So your Active Directory replicates back and forth as a full-blown Active Directory server. That way you have a full-blown copy. If something happens at your standard site, you now have another off-site copy that's a full environment. I can do things with SQL, and then I could do log shipping or mirroring and have a copy of my SQL data up inside Azure as well. I can do file services using distributed file services, file replication services, or other aspects to have a copy of that file server up there. I can do the same thing with web servers and basically do X copies, robocopies, or other copies of that web server data and have web servers in both sites. Or I could just have my servers up inside Azure and have my customers hit them from the on-premise network. They're just going to be accessing them across that VPN tunnel, just like they would from a remote data center. In addition to this, I can do things from the external internet side here as well. And so I have that nice fully connected internet connection where I can access these services. So what you design is really up to you in how you use it. Certainly for a disaster recovery environment, if your corporate environment is down and you can bring that and spin up and have all your services available up inside Azure, you could have your workers work from home accessing it through the internet. And you could have that VPN terminate there, or you could have you could do a VPN to that, or you could have some other direct access service, depending on how you need to design your environment. But it's certainly another nice tool to have in the belt. So what we're going to do is look more at the pieces that support this then at the networks. So we talked about VM sizes, supported workloads, software licensing, VM portability, the VMs and clouds. The next piece after we can take our break here. The next piece we're going to move into is we're going to look at the storage and the networking behind this and what we set up first in the lab before we spin up our VMs. And then we'll move into that lab section as soon as we finish the networking and storage. So we're going to take a short break so that everybody can take a bio break before we get back into this. And I appreciate everybody. At some point, everybody's been going over lunch on this event today. So thank you for that.
Just one more thing, Brian, just to let everybody know, we'll go a lot deeper into storage and networking, including VPNs, et cetera, after this break.